Okay, now in the second part of this, okay, what we have is initially it will start with the multivibrators. Okay, multivibrators are the electronic circuit which are used to generate two states and also to implement two state devices like oscillators only or timers and flip-flops. So where these multivibrators are used, where we require two stages, something like stage 1 and stage 2. It can be some voltage also, or higher voltage or ground, or logic 1 or logic 0. Okay, so there are three types of multivibrators. First one is a stable multivibrator. In these kind of multivibrators, outputs keep on changing. So if it is like at stage 1, it will be 0 and again back to 1, 0. It will keep on changing from one state to another state, like 1 to 0 or 0 to 1 for digital, or something like for 0 to VCC and back to 0, 0 to VCC in case of analog. Okay, and monostable multivibrator, if you consider, in these kind of multivibrators, the output will remain in one state. As you can see, it will be either in one state, not like logic 1. It may be logic 1 state or logic 0. It will remain there, okay, until until an event is triggered, external event. Okay, so what is the meaning of this? As you can see, this pulse is like a triggering event which will force this to change from 1 to 0 up to some time. Again it will come back to its original state only, that is 1. Okay, so something like a smoke sensor, after sensing a smoke, it will change, the action should take place, something like that. Okay, so something in the same way, bistable multivibrator, in these kind of multivibrator, output will remain in one state only until and unless a external event or a triggering takes place. Okay, so previously what we have seen, there also we require a triggering pulse, here also we require a triggering pulse, but in previous state, after receiving the triggering pulse, it after some time it used to change the state, but it will not change, it will remain in the same state until the next triggering event takes place. Okay, so when that takes place, then only the change will take place. Okay, is that clear? So something like, again, a smoke sensor. So once you are able to clear the smoke, so that sensor will stop to work in terms of beep, I am telling. Okay, so based on this, we have to consider the single stage stable oscillator. Okay, single stage stable oscillator. So already we know the meaning of stable, which will be able to produce continuous oscillation from one state to another state. So in this particular topic, it is very simple. It will vary from plus V to minus V, or minus V to plus V. That's all. Okay, so for this you need to just recollect the op amp output voltage definition. How V out is defined: voltage gain multiplied by non-inverting terminal minus inverting terminal voltage, correct, in the op amp. Okay, suppose if I consider, if V1 is very much greater than V2, but V1 is not equal to 0, so in that case, what will be the output? Output will be equal to A into minus V1, which is nothing but a negative value. Similarly, I forgot to write the equation for plus Vsat. So if you consider for plus Vsat, or this equation like minus A V1 only, it's another simplified name. What we have given is minus Vsat. In the same way, if I consider V2 is very much greater than V1, but V2 is not equal to 0, what will happen? You can neglect V1. So it is something like, you can consider V2 as 10 volts, V1 as 0.0001 volts. So if you neglect 0.0001 volt in terms of the 10, only 10 will remain. So it will be like plus a v1, sorry, plus a v2. In that case we can have that like plus v saturation. So that is the maximum point, we can say maximum positive point. This is the maximum negative point, we can say. Okay, so by considering these equation 1 and 2, okay, so in figure 1.4.9 what is there, okay, so this value of v and minus v, they can vary up to only up to these values, minus av1 or plus av2. Okay, so if I consider such conditions, okay, for analysis, if we assume that capacitor C is initially uncharged, so any capacitor, if you consider like uncharged, means it indicates the zero voltage. Zero voltage is represented by short circuit. If you replace this capacitor by short circuit, what will happen? This V1 will come directly in contact with the ground. In that case, what will be the V1 value? In that case, V1 value will become 0. So if that is the uh, value, so then what will be the V out value? If V1 is 0, already we have seen here. If V1 is 0, what will be left? What will be left is A into V2. So which is nothing but, just a minute, which is nothing but what? Plus Vsat. Okay. So in the same way, if you consider the other case, so that will be minus Vsat. Okay. So this is for the case V1 is equal to 0. Why it is 0? Because capacitor is uncharged. So if it is uncharged, so that means it will directly make V1 to be connected with ground. Okay, so as it's getting connected to ground, now since V out is equal to Vsat, the capacitor C will start to charge. So that means what? Now physically it is connected, but as output what we have, feedback, if it is a positive value, so it will flow through ground only. Okay, so while going through that, it will come in contact with the capacitor which is there physically, but it is uncharged. Okay, so capacitor will start to charge up to its maximum value. Remaining value will be terminated to ground only. Okay, so hence what happens, it will be able to give you a V out value which will be equal to plus Vsat only. So at this plus Vsat, capacitor will be charged. Okay, so through R. Okay, so now as V1 is greater than V2, V2 can be obtained by voltage division rule. Okay, which is nothing but what now? Where is V2? V2 is here, as you can see. It is connected over here. If you take a multimeter and keep the two probes here and here, so you are measuring the output voltage across R2, which is nothing but V2 only. It can be measured with the help of voltage division rule, which is nothing but what? Main voltage multiplied by R2 divided by R1 plus R2. Okay, so main voltage in this case, it will be acting like the saturation voltage. Okay, which is going through what? Capacitor only. If it is going through capacitor, it will charge up to Vc. So this will become what? This V2 value will become what? R2 divided by R2 plus R1 into plus Vsat. In the same way, if you consider for the other case, that will become like minus Vsat. Okay, by considering these things, now what will happen is, this is our actual what you can say, maximum and minimum points for plus Vsat and minus Vsat. So as if V1 is 0, Vsat will be at plus Vsat maximum value. If the value of particular thing is at v1, or you can say if v1 is 0, output will be equal to plus vset. If v1 is equal to v1, so vout will not be equal to plus vset. If v1 is equal to 0, it will be coming down up to minus vset. So it is changing its state from high to low, then again high to low. Okay, in this way the circuit will work. So just you need to analyze this and write it. Okay, additional analysis is given for your reference. You may consider or you may neglect it. Okay, similarly, based on the same concept, what we have is crystal oscillator. So in crystal oscillator, we don't have any circuit. It will be having a crystal silica, which is designed with respect to the desired components, which will be able to produce the required frequency. Okay, so what we do is, if you remember that common emitter RC phase shift oscillator, in the place of RC 3-stage RC, we just put a one crystal oscillator, which is shown as X of C, which will produce the required frequency. Okay, so it is just like what you can say, like a spect. If you are unable to see the things clearly with the 2.5 plus 2.5 lens, if your number is changed to plus 3, so what you do, you need to change the lens. Okay, so you can keep the frame as it is. So in the same way here, just if you change this required oscillator, so it will change the crystal, it will change the required frequency. Okay,